Hi, and welcome to our Codelab. In this lesson, we're going to look at connection states. So it's a bit less on code and more on state machines and how they affect the things that they are doing. We're going to focus on one state machine specifically. Let me share my screen for that. We start in WebRTC, we've got a connection state machine, and as any connection state machine, it will start with new, which is a state that we can't really reach. Okay. Once we start the session and open the peer connection, it will move towards the state connecting. That will happen once we exchange the SDPs for the offer and the answer.
And the ICE candidates.
Yes. Now from connecting, we will move towards the connected state if we got connected, which means that we've got media flowing across both ends and everything is connected. If all goes well, next we're going to simply close the connection. Sometimes what will happen is that we will move from the connected state to the disconnected state. This can be something transient, like packet losses, or we didn't get stun responses or something like that. And in such a case, we might move back from disconnected to the connected state. So the disconnected state is a kind of an indication that things are bad, but they might be changed for the better. One more thing that can happen is that if we start a session and we try to connect and we fail, we'll move from connecting state directly to the disconnected state. Okay, and then we're not going to go back from there to connected. From all of these three states, connected, connected, and disconnected, we can move to the failed state. And the closed state is reachable from everywhere. Okay, what I want to do now is to check how that happens within the flow of the call. Okay, so let me stop sharing. And Philip, I think it's time for you to show how we run that in the code itself.
Yes, so first we're going to look at the happy pass. So we have our session, it's up and running. And we do establish a connection. We should probably mute because otherwise we get our favorite echo.
It's working.
It's working. You can hear it. So we have these the logging for the ICE connection state change and the connection state change.
So I see connection state change connecting. Then there is connection state change connected, a few lines below. And then there's all the packet losses from that other lesson that we had. All of the, the bitrate messages.
Yes, and that's what happens here. So that's the happy pass. We've covered that.
Wait, can you shut down the call just for the fun of it from the other end?
Yes, so we can see nothing is happening here. We see a signaling state change to closed, but that's because we call closed and Chrome has a box there where they do that state change. And we have code in the Codelab that when the other end closes the tab, it will try to send a by before. So let's remove that code. It's at the bottom of the file, and it adds a event listener to the before unload and tries to send a byte to each peer. So if we don't...
what's happening now when we run? So this is a bad server with bad signaling at the moment, right?
Yes.
Okay.
And when we disconnect, when we close the tab, the other tab, we still have time to run a little bit of JavaScript code. So we can try to send a signal to the peer and close the session in a clean way.
Okay, so now want to close the session in an unclean way because that's life.
Yes, that's life. You need to deal with it.
Yes.
So we're starting the server again. We're going to new session, muting, and we go to the other tab, and almost no echo.
Okay.
So again, we have connection state change to connecting and to connected.
Let's go kill it.
Let's go kill the other tab.
Yes.
So we see connection is closed,
Mm-hmm.
and we wait for things to happen.
Okay.
Oh, we have an ice connection state change to disconnected and a corresponding connection state change to disconnected.
Mm-hmm. And we're waiting for failed. And here we got failed.
Failed here.
Great. When is it going to get closed?
Well, in the current code, there's no handling for that.
So we will be stuck on failed forever.
Yes.
Okay.
And one thing we could do in this case is to try an ice restart. So sending a new offer to the peer with new ice credentials, and if the peer never responds to that, we know it's gone.
So the Codelab that we have now just takes all of these states and logs them into the console, which is great, but in real life, we'll actually need to handle them.
Mm-hmm.
It means that for disconnected, we should probably wait a bit to see if it goes back to connected or if it shifts toward failed, but we should at least show the user that something is bad over the network.
Yes, for example, if you go to disconnected, you can start blurring the picture a bit, but then you might have a blurred picture which is still moving because that state is based on stun and not RTP, and all kinds of fun stuff like this.
Okay, and then once we hit failed, we need to decide, do we want to go to an ice restart type of an implementation or to just close the connection? That it's up to us as the implementers.
Mm-hmm, exactly.
Okay.
So one other thing I want to show is the unhappy paths, and we can simulate that in the Codelab by doing weird stuff with the ice candidates. So we have a code block here in the ice candidate event listener.
Okay.
Which I'm going to uncomment now. So what it does is it takes a candidate, splits the candidate, and replaces the port, which is the fifth element in the candidate string,
Okay.
by 10,000.
So it might actually work at some point in time.
Yes, 1 in 65,500 something. And well, no, it's not going to work because WebRTC doesn't bind to the low ports below 32,000. So it will never work this way.
So what's going on is this. We are causing it to fail simply because we're messing the candidate so they can't connect, because I'm not going to try and connect to the right location.
Yes.
Okay.
And in real life, that can happen when you, for example, don't use a stun server or don't use a turn server and have two people on different networks connecting.
Oh, and I've got a firewall that just blocks everything anyway.
Yes, a firewall that blocks all UDP. So let's start the server. Add a new session. Mute audio. Great. Well, I don't need to mute audio this time. So what we see here in the console,
it's connecting.
The ice connection state goes to checking and connection state goes to connecting. And we have a ice connection state change to disconnected and a connection state change to failed. And
again, we need to simply close that in our logic. Or
yes.
We try or whatever.
Yes. I mean, if we try to do an ice restart when there's an initial failure, that doesn't make much sense. We can just say, we can't connect.
Okay.
And an ice restart is not going to help. And what you can do, what is covered in your architecture course, I think, is that you can look at what kind of candidates you gathered and can determine if one of the ends was on a network that blocks UDP, for example.
Okay. Okay, so we've looked at the connection state, seen how we move from one state to the other, and understood that there are a few states that we need to decide what to do, and this is why we haven't covered them within the actual code that we have for this Codelab. We'll leave it up to you to make that decision in your own application. So thank you for joining this lesson, and again, see you in the next one.